One, how the so my standard procedure, regardless of who the sub is, even if it's Miss Price and I know her really well and we text and whatever, I always ask you guys how you feel the lesson went. So, do you understand it? Are there any questions left? How was the homework? Yeah.
Okay, so what he did was he basically just told us the questions and then let us work on our own the whole time.
Okay, sweet. Did it work? I mean, did you guys get through it?
Yeah. But can you also over, in 89, there's like 3 methods.
89. So, oh, sorry, I'm looking at yesterday. 3, 2, 1. Hey, it doesn't work if we all talk at the same time. Thank you. Sorry, you said 89 and.
Yeah. The first part, Ramon.
Sorry, hold on. I would not be doing my job if I didn't ask what is confusing to you about this. Hey, people. So I'm glad that we were all chatting. Like, I love that you guys are chatting, but I'm trying to hear what Miss Went's issue was here. If you had issues too and we don't fix them here, I want to hear from you, but I can't hear from everyone at the same time.
I don't understand how she got, I understand that there's one, 3/4 and 1 3/8, but then I don't really understand how she got 5/8.
Okay, so we talked at length. We being myself, Tom Kazmarek, the head of math in Worthington, and Brian Genius, yeah, his last name's actually Genius. He's one of the tech guys and he's very sciencey. He's like friends with Cabilo and Estes. Of how you think about dividing fractions. Hang on for just a minute. So if I talk conceptually about dividing fractions, it's a very hard idea. We're going to take something that involves portions and divide it by portion. Not divide it into portions, but divide it by portions. So what we're doing here is saying if I had 1 3/8 and I wanted to cut it into pieces of 3/4 size, how many of those could I have? So Ramona takes the whole 1 3/8 and says, well, really, instead of cutting into 3/4, I can think about cutting into 6/8 because they're equal. Are we all good there? Yeah. Ramona's just talking about equivalent fractions. So then she takes the amount that was 1 3/8 and looks at, here's 6/8. I can take that portion. I have one of them. Sweet, dandy. There we go. That's a 3/4. Then, now that's really 1, because that's 1 3/4, right? So this part is 1. And that's where she says, there are really, there's 1, sorry, it's right at the beginning. Sorry, I shouldn't have even circled the and. That's just that thought, okay? There's 1 3/4 and 1 3/8. Okay, so then, let's switch colors here. Then there are 5/8 left over. But that 5/8, what we're trying to figure out is how much of a 3/4. So, since 3/4 is 6/8, and I wish they just would have started with 6/8 from the get-go. Since 3/4 is really 6/8, this is where it gets confusing. Those 5/8 are 5/6 of another group of 3/4. I wanted to get us to that point of anger. Take us somewhere easier, right? So, flip to your notes. Not that one, this one. 2.5 divided by half. This will make sense. Draw me 2.5 pizzas. Try to put them close together so that this is actually going to represent a number line. So I have 1 pizza, 2 pizzas, half pizza. Well, 2 and a half. If I divide by a half, I am saying how many groups or pieces or whatever you want to say of this size can be made when I start breaking apart that. We know this answer, right? We already, because we can think in pizzas rather easily, you're like, well, duh, there's 5. But the reason why is when we go a half, there's my 1 half, then 2 halves, then 3 halves, 4 halves, and 5 halves. That's what we did over in the textbook, but with much uglier numbers. So, if I change this, right, now just watch for a minute, into something much more complicated. I should change color to iterate that we are changing the problem. By 3/8. Right now, it's visually, this is going to get goofed up for a second, but I think we're all, you can all stick with me. So if I slice my pizza into 8s, part of the first group, there's 3/8. You with me? Second group, that's 3/8. Are you with me? To make my third group, I have to dip into the second pizza, right? So then, third group. You still with me? Fourth. Fifth. Sixth group, I gotta dip into the next pizza. So sixth group. I've now filled my whole sixth group, and I have a leftover, right? This leftover portion, this is where everyone gets confused, has to be represented somehow. Right, but what we're saying is, what is that leftover portion in regards to the group that I wanted? What did I want to make a group? 3 slices, right? Hopefully we're not just spacing out, because I'm trying to get that conceptual barrier broken down. Hopefully we're not just spacing out, because I'm trying to get that conceptual barrier broken down. So we want 3 slices for a group, right? How much of a group do I have left over? 2/3. So my answer becomes 6 2/3. Because I have 2 of what would make a group of 3 left over, unable to make an entire group. That is what was being done right here in a more complicated manner. Not really more complicated, just harder numbers to get your head around. And pizza makes sense, right? Make it something we can make sense of. Does that now kind of make sense? What they were doing conceptually. This is not an entire, I wish it was a different color. This is not an entire group of 3/4. So what we're saying is 5/8 is what portion of a 3/4. And since 3/4 is really 6/8, what we have is 5 of the 6 that we wanted. That's how they got 5/6. We wanted to make a group of 6 pieces. We only had 5 pieces left. We have 5 of the 6. Does that make sense? Thank you for asking. How many people were actually confused on that and you were just like going to let it be confusing?
I tried to figure it out.
Bad! I'll do like my dog. Bad! Do not let yourself be just like, screw it, I'm confused. No! Ask the question! Make me earn my money. I'm here to make sure you understand. Okay, don't just read it. This is one of the most complicated things we will ask you to do this year. Divide with fractions. Now, the olden way that we would do this is just teach you a trick and then you move on. Yeah, keep, change, flip. That's the trick. But then you're asked on a test, okay, explain what you did. Well, I did keep, change, flip because that's how you divide fractions. That's like 1 point out of 4. Like seriously, they grade on like a 4-point scale for a lot of problems. There's a rubric like did it like meet nothing? Did it meet a tiny bit? Half of it, most of it, or all of it, right? And that would get you like a point probably out of 4. To get 4 points, you would have to explain, I had this much to start. I started breaking into the groups the size that I had been asked to. And then when I got to the end, I had this many pieces out of the pieces that I wanted. That's how I got my final fraction. Cool. What other problems then from yesterday's lesson were confusing? There. Boy? Hugh?
I thought it was you.
I'm not quite sure.
I would say you.
We're going to capture this.
No, it's
Who are you?
No.
Okay. Actually, Hugh's is really good. Hold on. Shh. Stop saying that. That's the worst thing you can say. I'm serious. So, back it up a second. Those of you who were like immediately saying, oh, yeah, I get that. Yeah, that makes sense to me. How do you think that makes the person feel who doesn't get it? Right? Like, I have 5 people around me saying, oh, yeah, that makes it super. I get that. And I'm going to be like, yeah, I don't get it. Right? So be careful how we're talking. Let's try to cut out those like, oh, that's easy for me. Oh, let's try to support that we think differently. We're not all going to get stuff at the same time. So Hugh's work. Hugh is a giant fan of the giant 1. See what I did there? So he sees that if I multiply a fraction by its reciprocal, wipes out the fraction. It turns into 1, right? Like, how many halves make a whole? Well, 2. That's just multiplication by the reciprocal. How many thirds make a whole? 3, right? So we get that. So Hugh, or however you say his name, sees that if we're dividing by a fraction, I don't like that. So he multiplies by its reciprocal. But to do that in the denominator, he has to do it in the numerator. Are we with me up to there? No matter what. Okay, where? Where is the confusion?
Okay, so why is he doing 4/3?
Okay, so again, let's back it up to something easier then. I have 8 pies. Say we're coming up to pie day. I want to cut them into thirds. So I'm going to do 8 divided by a third. Right? How many groups of thirds can I make? Like how many, say I'm going to give prizes for pie day. Right? I'm going to give away thirds. How many thirds will there be in 8 is what this is asking. So forget about a fraction on the top. Right? Make it easier for a second. You walk up, Mr. Hudson, there's an easier way to do this. You know that there are 3 thirds to make up a whole. Now really I should make this. The reason I do this, I was about to make it horizontal, my fraction bar, but the reason I do this is in a complex fraction, I want to know what the main bar is. This is my main bar. It is 8 in the numerator and 1/3 in the denominator, as opposed to, is that 8 firsts divided by 3, or is it 8 over 1/3? That's why I use a diagonal slash in a complex fraction. So just tips and tricks that if I were you, I would try to adopt. So I can multiply a third by 3 and get 1, because I would love a denominator of 1. That would make my life so much easier. But I can't just do this. Right? That modifies my problem. If I do it down here, got to do it up here. Hence, the giant 1.
Oh, 1.
Right? So he's doing the same thing on top and bottom. Okay? Multiply. This is just 1 because it's the same thing over itself. What's 8 times 3?
24.
I will get 24 thirds out of my pies. If I cut 8 pies into thirds, I will have 24 pieces. That is what he's doing here. However, why this seems complicated, all he's doing is reciprocal of the denominator. But when he does it in the numerator, this becomes really complicated. But this is over 1. What's division by 1 do?
Make it the same.
Nothing. Yeah, it keeps it the same. So that's how we get to here. That division by 1 doesn't matter. We take it away. Then we rewrite it as mixed, and then we just reduce it. They divided by 4 on top and bottom. Questions still remaining about that solution process?
Do you only do that for the complex ones?
Well, yes. So let's say, so write this down. Let's play with one of these. Let's say we have some leftovers from a cookout, and because it makes sense to us, our brains can like visualize this, right? Yeah. So let's say I'm going to bring up food that I know we don't have in the building, so you won't all hate me. Let's say we have 5 1/3 watermelons left over. And we want to have a watermelon eating contest. And we're going to have a watermelon eating contest involving quarter melons. So we're going to divide this into quarters. So 5 1/3 melons divided into fourths. Now, make this problem easy for me. How many fourths? 20, right? Every melon will have 4. That'll be 20. How many fourths? Which is bigger, a third or a fourth? Third. So there will be a fourth in the third, right? So, if you want, don't write, just watch for a second. Right? We know there's 20 fourths in that. Then modify this to just a third divided by a fourth, because that's really what we have to worry about. What's that crap at the end left over? If you didn't do this, you'd end up with 16 thirds over a fourth. You'll end up with the same answer no matter what you do. Well, not no matter what you do, but either of these ways. So pick a way, and then write down your next step. You're either going to have 16 thirds over a fourth, or go ahead and bring it. Now, I'm going to erase this and actually take the 16 thirds method, because I know this will confuse some of us. So if I don't take the 20 right away, and I keep this all together, I probably need to move this. I'll leave it over there. And I have 16 thirds over a fourth. I've done nothing but make my mixed into an improper. So please write down something. At least fake write something down so I think you're like with me. I mean, let's just be honest. If you're going to fake write something down, you should just really write something down.
It's not with your time.
How do I get a fourth to be a 1? No. Multiply by its reciprocal. What's its reciprocal? 4 over 1. So if I want my denominator to be 1 to make my life easy, multiply by 4 over 1 and multiply by 4 over 1. We know the denominator wipes out. Nothing to think about there. But now my numerator, I got to go straight through the top and straight through the bottom. 16 times 4. Anybody real good? Turned on this morning? 64. This gives me 40. This gives me 24. We get 64 over 3. Forget about the division by 1 because that doesn't matter. So really all we care about is the numerator. 21 and 1/3. Because here's the trick. If we pulled out that 20, there is a 4th inside this third. Thirds are bigger, right? So we don't just get 20, we get 21 and a leftover. But that is a third of a fourth. This is not a third of a melon. This is a third of a grouping, a third of what I was trying to make. This is not a third of a melon. This is a third of the groups, which in this case were the quarter melons. So I really could label that quarter melons if we wanted to. Who's confused? You can turn your desk, literally the direction of your desk if you want. I've turned it the other way and then people turn it back, so I don't quite know like what's going on. Yeah. You don't get what? Why we do what we do or how we do it, huh? Hold on, let's figure out something physical. Like, I'm trying to think of something tangible that we can. Somebody make me up a problem with the first number being less than 4. We're gonna do this like when magicians are like, dude, or we're gonna live math this, right? Somebody make me up a problem involving a mixed number that involves 3. Don't make it stupidly ridiculous because we want people to understand this. Oliver?
3 and 2/5.
Okay, 3 and 2/5. Now somebody else tell me how big of groups I then want to make that have to be less than 1. Will?
1/5.
Don't do it. That'd be too easy because I'm working with fifths. Thirds, sure. Love it. Groups of thirds, right? So please write that in your notes. My challenge to you is can you actually figure out what that is? Now, visually, I have 1, I have 2, I have 3. Then I got to make this represent 2/5, right? So how can I make fifths? I can fold this into 5s, which is kind of difficult. Well, right, but I still have, I'm going to cut it to make that be only 2/5, but I have to make fifths first. I'm going to take the long way and count squares. So I should just know how big this paper is. 2, 4, 6, 8, 9, 12.
Oh my god.
It's essentially 40. What's 40 divided by 5?
8.
So that's a fifth. Okay. How many fifths would I need to take off of here then? Hold on, listen to my question. How many fifths would I need to take off of here? 3, right? If I have 3 and 2/5, I'm missing 3/5. So here's a fifth, here's a fifth, here's a fifth. This is 2/5. Do we agree with me? That's twice as wide. So.
Good morning. Stella Campbell, please come to the office. Stella Campbell, please come to the office. Thank you.
But before I do that, Actually, never mind. We'll work all vertically. So guys, hopefully you're paying attention. I'm trying to really, I know I've said this, but the conceptual barriers of dividing fractions are huge. So here's the amount I don't have. Here's my 3 and 2/5. Now, I need to divide them into thirds, right? How many thirds? 3. How many thirds?
3.
Well, together now. 6. How many thirds?
9.
9. Now, wait a minute. Crap. Now, I can fold thirds more easily, right? On paper, thirds is kind of. No, wait. We had 40 squares. I know how many. Well, what's 40 divided by 3? If I think about a third of the paper, make it easier. Do 41. 30. 39 would be easier. 39 divided by 3. 13. 13 to 14. So wait, so I say, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there on. So what I'm going to end up left over, how many thirds did I have already? 9. I get another third out of here, right? So now how many thirds do I have? 10. And the question is, what the crap is this? Right? What? Now, we knew that if it was like 13 to 14 blocks wide, it was a third. We knew that if it was like 20 blocks wide, that'd be a half. Our fifths were 8 blocks wide. This would be really tough if I'm just thinking visually, right? But mathematically, we can instead reset my whole situation with a lot more folds. This 3 and 2/5.
I didn't do that.
Hold up. This 3 and 2/5. Now it's weird because we start thinking in fifths and then we move to thinking in thirds. But we start with 3 and 2/5, which is really how many fifths? Make this improper is what I'm saying. We really have 17 fifths, right? We want to cut that into thirds. Now, the old way that we would have just taught you guys is keep, change, flip. Now, I'm going to show you why. So back in the old days, we would have just said, just do this. Flip the second thing, change this to multiplication. Here's why. We would have had you set up the division, divide by a third. And then you would have been like, I don't like complex fractions. Wah! And then we said, well, don't worry. You can multiply by the reciprocal. Giant 1. The denominator doesn't matter. Right? It all ends up disappearing. Here's your keep, change, flip. What the keep, change, flip process is multiplication by the reciprocal of the denominator. But that's complicated. So we sold you guys the short straw, and we said, just keep, change, flip, memorize that, and you're fine. No. You need to understand why. So, I've got all this stuff, right? My thirds, my extra. When I do this math, I now have, what's 17 times 3? That's a fun one.
51.
51 over 5. I made 10 of my thirds, right? These 10. And this doodad was not a fifth of a piece of paper. It's not. We can see that. It's a fifth of what I was trying to make, which is a third. It's a fifth of a third. If we go back to the beginning, this would be 1/15 of the paper. But now, because the groups I'm talking about are this big, leave it. Now, because the groups, this is my whole, right? This is a group. It is a fifth of this group. Does that make a bit?
Now it finally makes sense.
This is so difficult to describe.
Keep.
No! Don't just keep, change, flip. Understand what we're doing. What? Okay, hold on. I'm like out of breath. It's like a workout.
I do that.
I haven't been climbing in a few days. I'm out of it. All right. Yeah, what about 390, 391? Like, what else did? So, you're all gonna be really upset about this.
No.
I was being facetious.
How could you?
Is this yours? This is the wrong slot. So we're second class of the day, second slot. So this is 2. You can't really see the sticker. That's 2A. That's my high school class, my 8th grade. Well, you guys could be in there. Can we address for that? Can you do it on a 17? Yeah, I'll check you back today. Right, but that's not an excuse to not be your home. Yeah, but you kind of said it. All right. Other questions from the lesson from yesterday? Or from homework? We will, if there are no other questions, we'll move into the next lesson, but we're not going to get done with enough of it for me to want you guys to really have the practice assigned. We've been moving quickly. My goal is just have the assessment this week at some point, probably like Friday. We're fine. What other questions do we have? What do you mean how? Yeah. Tomorrow's well, we have 3-3-2 to do, and then 3-3-3 in the fifth. So depending on how we decide to close the chapter, will depend on what we really like, what timeline we take. 9.
387C and D was confusing. For me at least.
Okay, let's do this. Let's do this. No. Thank you, though. Highlighters. Because our unit is highlighters, okay? Don't care about colors here. We are equal opportunity highlighter providers. So let's make sure that we can have eyeballs on this table. I just need these to not disappear. So, table team, how many highlighters do we have? 10. Now, how many groups do you have? Right now, how Izzy's holding them, how many groups do you have? One, right? Like they're all together. Can you take the quantity you have and split them into 2 groups? Show me. We have 2 sides. Okay, great. Can you take the quantity you have and split it into 4 groups? Let me get out my hedge trimmers here, and we'll chop these in half. We could, right? We'll break some highlighters, and actually that's how you can make some black light glowy bottle things. Talk to me later if you want to know how. Take one of these, break it in half. I'll tell anyone that wants to know. So you could, right? We could break it into 4 groups. So put it back together in 1 group. So right now this is 10 divided by 1. Then we showed 10 divided by 2, right? Now take those, make me 0 groups. Well, that would be subtraction. Make me 0. Just divide those into 0 groups. Fine, you're a pessimist. Split these into groups of 0. Like just put 0 in each group. What? Well, if you have groups of 0, how many groups did you make? Sorry, grab your seats again. I was about to walk away and leave you with all these. In your notes. Please, back in your notes. In your notes, write 10 divided. So we did 10 divided by 1 just to start. One group. How many was in the one group? 10. We did 10 divided by 2, and we were able to see each group would have. We talked through the idea of doing 10 into 4 groups and realized we would need some hedge trimmers or something to cut those highlighters in half because we'd get 2.5. So then we talked about 10 divided by 0, and I like it that Ava was like, well, yeah, here. I like gestured to like the table and was like, well, yeah, there's a group of 0, there's a group of 0, there's a group of 0, there's a group of 0. How many groups of 0?
0. Infinite. What?
Wait, so what's the difference between 0 groups of 0 and infinitely many groups of 0?
Because they're all 0.
That doesn't make any sense.
They're all 0. You keep on losing your pen? Does it have to?
Undefined. Hey, Bougainville. Before I wrote this up here, do you know what I was going to say division by 0 causes? No. Zivit. No. There's no answer. It is impossible. You try to do it in a calculator, it will spit back an error. Try to do it in a computer, it will tell you you can't. This doesn't make sense. So please write this down, considering you didn't know it. Correct. That's why we're discussing it. The idea, you can always borrow anything you want. Yeah, just move. The idea of making 0 groups when you start with something doesn't make sense. The idea of making groups of size 0, well, you could make infinitely many groups or also 0 and they're the same at the same time, and this doesn't, your computer explodes, and like literally your head, you get like steam or smoke or whatever coming up. So, now, like most of the confusion with division by 0, people are like, oh yeah, division by 0 makes infinity. That doesn't make any sense at all. Because if you turn around division, we can make multiplication going backwards. So, if this were true, and this gets into mathematical proof of how we decide things are true, like science, how do we know it's true? If, like a big old if, I was going to go lowercase, but let's go big old if. If 10 divided by 0 did in fact equal infinity, then what that would be saying, infinity times 0 equals 10. No! Right? No! That doesn't make sense. And that would hold true for any number we started with. This is why it doesn't work. It doesn't make any sense.
Also, if you were to do infinity times 10 equals 0, that wouldn't make any sense either.
What is 10 infinities? If infinity is the biggest number possible, and then you have 10 of them, well, wait. How did we get bigger if we were as big as we were? Also, things that don't make sense. And this rule comes from like, if 10 divided by 2 equals 5, then 5 times 2 equals 10. It's the division multiplication rule. Like, it will always hold true. This doesn't work. That's why it's undefined. That was more aggressive than I wanted it to be. My apologies.
You have to make it aggressive.
So this is proof. Actually, somebody asked you prove division by 0 is undefined. This is part of how you can prove it, because you make a nonsensical mathematical statement. I would ask my friends. What else? This has been great. I really appreciate this. We can do this anytime we need. If it's like, hey, we need to stop for a day and take questions and talk about things and conceptually get more understanding, I would rather sacrifice a day of forward motion than to have you move forward and not understand things. Yeah, like, oh, the foundation hasn't dried yet, but we're going to start putting the house up. Like, no, you need to let the cement dry. Like, it needs to be ready. That foundation needs to be solid. Yeah?
Then
undefined. So let's all make sure we notice all this. So this creates undefined, which also this symbol means the empty set. Now, don't confuse these two. This just means there's nothing in the answer. Undefined is actually a math word. Means it literally can't happen, won't work, like doesn't exist. But if we ask for the set of even prime numbers, there are no even prime numbers. But I can answer that. It's an empty set. There's nothing in the set. So that would be how we would represent a set that does not have anything. Undefined is how we represent things that literally cannot happen. Like, it mathematically breaks the rules, doesn't work. Okay? That's an art. Okay, so that's a really big argument of whether it's so I used a poor example. I should have used a different example. Because 2 is prime. Hold on. Prime numbers that are divisible by 4. Yeah, even was the bad example. I should have said prime numbers divisible by 3 or divisible by 4 or something else. I forgot about 2. Yeah. I mean, fractions inside of fractions for days. Right, there's some really complicated algorithms that involve fractions and fractions and fractions. All right, we are just about out of time, so here's the dealio. As you're packing up, please still give me a little bit of attention. We need to do 3-3-2 and 3-3-3 this week. We'll talk tomorrow on how we want to close the chapter, but depending on that is going to depend on when we assess. I try to avoid Monday assessments, but if we want to try to assess this week, we might have a brief chapter closure, like not long, like end of the day Thursday or something like that. So think to yourself over the next day or whatever, how comfortable are you with the material we've been learning? That's really what I'm going to be asking. How comfortable are you with this stuff? Have a great day, guys. What?